Let us now discuss the second method of polarization, and that is polarization by reflection. So let's say we have a denser medium which is placed in air, let's say. Let an unpolarized light be incident from air onto the denser medium. So you can see here that this light consists of vibrations which are along the plane of the board, denoted by the arrows, and the dots here. The dots represents the vibrations which are perpendicular to the plane of the board. So this light which have more than one plane of vibration, this is unpolarized light. Now when light is incident like this from the air onto the medium, the part of the light gets refracted. Part of the light gets refracted, whereas the rest of the light gets reflected. Okay? So it is found that if light is incident at a particular angle of incidence called the polarizing angle denoted by theta p, then the reflected light becomes completely polarized, whereas the refracted light becomes partially polarized. The reflected light becomes polarized on a plane which is perpendicular to the plane of the board. So you can see here that only the vibrations which are perpendicular, the dots perpendicular to the plane of the board, are present on this reflected light. So this, since it has only one plane of vibration, this is a completely polarized light. Whereas the refracted light consists of vibrations which are mostly along the plane of the board and some vibrations which are perpendicular to the plane of the board. So this is partially polarized light. Okay, so it is found that when unpolarized light is incident at a particular angle called the angle of polarization, the reflected light becomes completely polarized, whereas the refracted light becomes partially polarized. All right, and the angle between the reflected light and the refracted light is 90 degrees. This is nothing but a law known as Brewster's Law. Now what does this law say? According to this law, when unpolarized light is incident at polarizing angle theta p on an interface separating air from a medium of refractive index mu, the tangent of the polarizing angle is equal to the refractive index of the medium and the reflected light becomes completely polarized, whereas the refracted light becomes partially polarized. That is, tan of theta p is equal to the refractive index of the medium. Let us prove this law. This law follows a very straightforward proof. Now, it is found that when light is incident at polarizing angle, the reflected light becomes perpendicular to the refracted light. So this angle between BC and BD is 90 degrees. So therefore here, the angle CBD here is 90 degrees. Let's call this some equation 1. Now in figure, what is the sum of theta p plus angle CBD plus angle R? This is 180 degrees, yes or no? This angle plus that angle, that is 180 degrees. So theta p here plus this is how much? 90 plus R, that is 180 degrees. So therefore, what is the value of R here? This will be 90 minus theta p. Call this some equation 2. By Snell's law, you have what? According to Snell's law, sine of I by sine of R, that is equal to mu, right? So here, if suppose I is equal to theta p, then R will be how much? Will be 90 minus theta p. So therefore, replacing these values in the Snell's law, you have sine of theta p by sine of, instead of R you write 90 minus theta p, this is equal to mu. Okay, and we know very well what is this denominator becomes. This becomes cos theta p, and that is equal to mu. So therefore you have tan theta p is equal to mu. This is nothing but Brewster's law, which is the